Hi, I am Sanjay Patel. Today we are going to discuss different types of discontinuities of a function. So first of all, let us recall the definition of a continuous function. We know that f is continuous. F is continuous at the point x is equal to a if and only if limit x tends to a, f of x exists and is equal to the value of the function f of a. So this is our definition of continuity we have done in our last lecture. Now when this is not true, so remember the meaning of this. First of all, we understand in this manner. If this is true, that means the function has a left limit at the point a and a right limit also at the point a. So f of a minus and f of a plus both exist. This both exist, and these values, left limit and right limit, and the value of the function all must be equal. So the function is continuous at the point a, then f of a minus and f of a plus, these two values must exist, and these all three are equal. So if we take the negation, one can think like this. So therefore f is not continuous or f is discontinuous at the point x is equal to a if and only if either this thing is not true or this thing is not happening. Okay, that means either I can say f of a plus or f of a minus or both does not exist. Does not exist. This is my first part. Or this and becomes or even if both exist. Okay, so I can write like this, or f of a plus and f of a minus both exist, but this is not true. These three are not equal. Means either we can have this situation, f of a minus is equal to f of a plus, but in that case this is not true, or I can say this, or I can have f of a minus is equal to f of a is not equal to f of a plus. In that case, the value of f of a is not at all important. So these are the three ways in which the function can be discontinuous or not continuous at the point x is equal to a. See, one clear negation of this, f of a plus and f of a minus both exist, means either this does not exist or this does not exist or both do not exist. So either this or this. This or means this or is our inclusive or. So let me highlight that. This is inclusive or, either f of a plus or f of a minus or both does not exist, then function will be discontinuous. Or this will happen, either f of a plus and f of a minus both exist, but one of these holds, that is either f of a minus and f of a plus, left limit and right limit are equal, but they are not equal to value of the function, in which case limit exists but it is not equal to f of a, and this f of a minus and is not equal to f of a plus, in that case left limit and right limit are not equal, so limit does not exist, so we don't have to worry about the value of the function in that case. Okay, so these three cases suggest to classify the function is not continuous. To classify the function is not continuous in the following ways. So let me draw a chart and explain this thing. So f is not continuous. F is not continuous at the point x is equal to a. Okay, that means, let me explain this. I can explain this way. So then there are two possibilities, 1 and 2. So the first possibility I am taking here is f of a plus and f of a minus, and is there, both exist. So we have to think further in this case. And another possibility is f of a minus or f of a plus does not exist. Here or means it can be true both the ways, does not exist, means both f of a minus and f of a plus may not exist. Okay, and the next thing I can classify further this first possibility again into two categories, say like this. Say suppose f of a plus and f of a minus exist, then again function is not continuous is given, f is not continuous is given. So this f of a plus and f of a minus both exist, then there are two possibilities in this case, and they are f of a minus is equal to f of a plus. So left and right limit both are equal, but they are not equal to the value of the function at the point a. Okay, and another way is this, that f of a minus and f of a plus, they are not at all equal, in which case whatever the value of f of a is. So these are the three possibilities in which function is not continuous at the point x is equal to a. And we name these three possibilities in this manner. We call this first part, this first possibility, as the discontinuity of the first kind. If this thing happens, then function is said to have discontinuity of the first kind. And if this thing happens, that is said to be discontinuity of the second kind or second type. Second kind. Okay. And if f of a minus and f of a plus both are equal but not equal to this, then function is said to have removable discontinuity. In this case, this is called removable discontinuity. Removable discontinuity. And if this thing happens, then it is called jump discontinuity. This is known as jump discontinuity. So this way we can classify the discontinuities of the function in this manner. So let us write a more precise definition, and then we'll take examples of different types of discontinuities. Some very important and interesting examples we'll be discussing. So let us start with the definition first. So definition of different types of discontinuity. Let f be a function from x to r and a belongs to x. This is given. So my first definition will be this: if f of a minus and f of a plus both exist and f of a minus is equal to f of a plus and it is not equal to the value of the function, then the function f is said to have removable discontinuity. Is said to have removable discontinuity at the point A. Okay, at the point A. And second thing, so we have discussed this case, this one, f of a plus, f of a minus both exist, and this is not true. I mean, this holds. Number 2, if f of a minus and f of a plus both exist, but f of a minus is not equal to f of a plus, then f is said to have jump discontinuity at the point A. Is said to have jump discontinuity at the point A. We'll see why it is called jump discontinuity and removable discontinuity in examples. Removable, as the name suggests, we can remove that point of discontinuity. We can redefine the function and make it continuous. Jump discontinuity suggests the function takes some jump at the point A. Okay, so we'll be clear when we take some examples. The third definition I want to write here is, if either this one or two holds, then function is said to have discontinuity of the first kind. It follows from this. If either removable discontinuity or jump discontinuity is there for a function, then that discontinuity is said to be of first kind. So, if f has either removable or jump discontinuity at the point A, then this discontinuity is said to be of first kind. Then f is said to have discontinuity of the first kind at the point A. F is said to have discontinuity of the first kind at the point A, or it is called ordinary discontinuity. Ordinary discontinuity. So remember these names. And fourth thing, or the fourth definition, is the last possibility. If f does not have discontinuity of the first type or first kind, then it is said to be of second kind. So I can write directly like this: if let me write in a different way. If the discontinuity of f at the point A is not of first kind, say is not of the first kind or first type, then f is said to have the second type of discontinuity, said to have second kind of discontinuity at the point A. Okay, second kind of discontinuity at the point A. So this also I can write in a different form, that is, or if f of a plus or f of a minus or both does not exist. In simple language, if one of these or both does not exist, then f has second kind of discontinuity. Second kind of discontinuity at the point A. So these are the four important definitions, and we will be discussing problems based on this. So let us recall again from this diagram. F is not continuous at the point x equal to A, means either this f of a plus f of a minus both exist, but one of these happens, or one of these two happens, or f of a minus and f of a plus or both does not exist. So f has either first kind of discontinuity or second kind of discontinuity. First kind of discontinuity are of two types, that both left and right limit are equal but not equal to value of the function, and here both left and right limit are not equal, in which case we don't have to check about the value of the function at A. So these are the three types basically of discontinuities. So we'll say take some examples of different types of discontinuities and understand what are all this. So in this connection, the first example, let me take the first one. Let f from R to R be defined as f of x is equal to x plus 2 if x is less than 2, is equal to 0 if x is equal to 2 and 2x if x is greater than 2. And our question is, discuss discontinuities of f and its type. Now, whenever we are solving problems of continuity or discontinuity, it is better to have a rough idea about the graph of the function, or we should draw a rough graph if possible. So, I am just showing you the graph of this. Let me take, just remember, the function is split into three parts. On left hand side of 2 it is defined as x plus 2, on the right hand side of 2 it is defined as 2x. So let me take again, let us draw y-axis. Okay, and let us now, this is origin, this is x-axis, this is y-axis, and the right hand side of the function is y equal to 2x, this for x greater than 2. So suppose somewhere I take so this is 1, this is 2, this is 3, this is minus 1, this is minus 2, like that. So for this 2, for x equal to 2, on this side, for x greater than 2, the function is a straight line. You can see here it is 2x. Let me show you again. For x greater than 2, it is fx equal to 2x. So it's a straight line passing through origin, but we have to consider from this point on. Say for x equal to, suppose this is suppose if I take here somewhere, say a point, this is corresponding to this, and now I am taking so we'll be getting straight line passing through origin. It will be like this, and so this is my y equal to 2x line which is passing through origin. Let me draw it proper. Let's shift here. And let us show that x equal to 2 here, and let me extend this. Okay, fine. And the other way, when x is less than 2, the function graph is x plus 2. So you can understand when x equal to 0, y is equal to 2 or fx equal to 2, and when x equal to minus 2, fx is 0. So this is when x equal to 0, y is equal to 2. So it is this. Let me use some other. And this is somewhere here it is, we have minus 2. So if I consider this point and I can join like this. Yes, let us rename that, which is not done properly. Say this point I consider as, say, 2. This is minus 2. So the line is passing through minus 2 comma 0 and 0 comma 2, and the line is y is equal to x plus 2. Okay, so this is my graph. You can see that function is not defined at this point is not there. Its value is something else. For x equal to 2, the value of the function is 0. So it will be here. This is the point on the graph. So the graph consisting of this blue line, this yellow line, and the point 2. That is our graph of the function fx. So clearly, function is a straight line for x less than 2 as well as greater than 2. So it is obviously continuous. And even from the equation of the function, you can say fx equal to x plus 2 for x less than 2. So it's a linear function or a linear polynomial. So it is continuous. And for 2x, right hand side also it is continuous because every polynomial is continuous. So for x less than 2 or x greater than 2, the function is continuous. So only the point of trouble is x equal to 2, which will be discussing in detail. So let me first of all note that f is continuous. F is continuous for every x belongs to R minus 2, because for x less than 2 or x greater than 2, the function is a straight line, which is always a continuous function. So let us think about the special case. So consider the point x is equal to 2. What happens at the point x equal to 2? We want to discuss the function's continuity. So for 2, let us find the left limit first. F of 2 minus, by definition we know it is limit x tends to 2 minus f of x. But what is the meaning of limit x tends to 2 minus? It means x less than 2. X goes near to 2, but from left hand side. And for left hand side, the function formula is this, x plus 2. I must write here x plus 2, because x tends to 2 minus, you can understand as say x is less than 2. X is going near to 2, but x is remaining less than 2. So we have this situation, and this x plus 2 itself is a continuous function. Its left limit or right limit at any point exists, and it is same as the value of the function. So I can now write directly x equal to 2 here, and I will get 2 plus 2, and that is equal to 4. So my first left limit is 4. This is my first value, left limit. Now I will find the right limit at the point 2. So for the right limit, that is f of 2 plus, we have to consider x greater than 2. X tends to 2 plus fx means x remains greater than 2. And for x greater than 2, we know the function formula is 2x. Okay. So remember simple way that x tends to 2 plus means you have to consider x greater than 2. Okay. For x greater than 2, function formula is 2x. This 2x is again a polynomial, and every polynomial is continuous at every point. So it is also continuous at 2. So its left limit and right limit and value at 2 are equal. So I can directly put x equal to 2 in this. So I will get 4. So f of 2 plus is equal to 4, my second value. From these two, it follows that left limit and right limit of the function both exist and are equal. So my first conclusion here is f of 2 minus is equal to 4 is equal to f of 2 plus, and both are finite real numbers, so both exist. Okay, so that means limit x tends to 2 fx exists and is equal to 4. But also we note that the value of the function at 2 is 0. We are given that f of 2 is equal to 0. So this is not equal to f of 2. So limit x tends to 2 fx is not equal to f of 2. Therefore the conclusion is function is not continuous at the point 2. So thus f is not continuous at x is equal to 2. Okay, and what kind of discontinuity is this? Both f of a plus and f of a minus exist. This is the thing, but they are not equal to the value of the function at a. So the discontinuity is removable discontinuity, and f has removable discontinuity at x is equal to 2. Okay, or you can say f has first kind of discontinuity at 2. Okay, and removable means we can remove this discontinuity and redefine the function and make the function continuous. You see here function value is 0. It is given in this formula of the function. So I have taken that point here, and that's why the function is not continuous. So let me change this value, and instead of 2 I will now take the point here, the value of the function here, so that I can join these two graphs and make the function continuous. So I can join these two, and what is that value? For x equal to I need, it should be 4. So this is somewhere say 4. I will define the function again and make it continuous. So clearly we can redefine f and make it continuous as follows. So if I take fx is equal to say x plus 2, if x less than 2 is equal to 4. Now this is the important thing. We are defining at x equal to 2 again, and the remaining things are as it is if x is greater than 2. So this is our new modification. We have defined the function at x equal to 2. Instead of 0 we have taken 4. So now then this function is continuous everywhere. Okay, so we have seen the first example of this discontinuities. We'll discuss some more interesting and more examples in our next lecture. So till then, thank you.